Hello, everyone. All right, so yeah, so we had discussed being able to manipulate a um, a collection of movies, right, that was being stored in our database. We had this set of movies stored in a MongoDB, and we had built a small user interface that allowed us to retrieve those movies from the database and be able to create new movies, delete movies, and update, whether we liked it or not, and increment the likes, and then update the records accordingly in the database. For that, we had implemented a couple of files here that describe the movie as a schema. Then the model that gave us the low-level uh, functions that allowed us to interact with it, create, read, update, and delete movies. We have built a DAO that allowed us to interact with the movies at a higher level, providing a high-level user interface, right? That's specific to the domain that we were working with, like movies, as opposed to the generic functions that the models give us. And then we wrapped the whole thing in a RESTful web API, right, that we could send either a post to create the movie, a get to retrieve all the movies, or update a particular movie, or delete it, right? And we wrote the handlers here, right, to handle each one of these HTTP requests, right, to retrieve, create, update, delete these movies. Originally, we had implemented it as manipulating an array, but then we replaced that so that we could interact with the database instead. So to practice this again, just so that to bring this, so that as you practice again, you become more confident understanding how this works. We're going to do the same thing with users and see how similar these are. Let's see. This is recording. Okay, so the first part is to define the schema for the user, or the structure of the data type for the user. What makes a user? Let's see here. We might have had already a couple of users. Okay, we have a user, Alice. I believe we had created this manually, just by adding the document. Instead, let's learn how to do that programmatically from Node.js and through Mongoose, the library that we're using to connect to the database. So let's create the schema. So we'll say that this is a users schema, and so we need to bring in Mongoose, the library, and then we can declare the user schema as a Mongoose schema, which defines the various fields that make up users. Right? So here you might have a username as a string, you have a password also as a string, you have the first name, last name. So all the fields that describe what a user is. You have an email, date of birth, the type date, Boolean. Okay. And so you can specify these fields as just the data type, or in addition, you can say that certain things might be required. So you can say that not only is this a string, not only is it a type of string, but it's also required. And perhaps the password also is required. So if I register with the my application, I need to provide a username and password. But in addition, I might say that the username, because I'm using it to uniquely identify the user, I might say that this is, but the password doesn't need to be unique. Okay, and I might do the same thing with other one of these fields. Okay. All right. Okay, so we have a schema. We might also clarify that this should be stored in a collection called users. Export this so that we can then define the model. Let's go here and define the model. New, just model. And again, the model just implements the low-level API that allows us to communicate with the database. And we need to declare a unique identifier for the model. So very common that we just use the same name as the variable of what it is that we're storing in that particular collection, and then the schema. Second argument. Break this up into ones. We export this, and then create a. So this already gives us all we need to be able to talk to the database, right? But it gives us some very low-level functionality, right, to talk to the database. Instead, we'd like to wrap that into something that's a little more higher level, but specific to our use case. So for that, we're going to create a DAO. So we'll import the model. Right. And we're going to just create here several functions that will give us all the CRUD operations that we want to implement. We're going to be able to create a user, create a user that receives a user object, and we're going to just insert that, right, using the user's model. Create user. So this is just basically a pass-through function, right, where we are wrapping a low-level generic function with a much higher level function, right, that is specific to our use case, which is create users or create movies, or all written in terms of low-level generic functions. So like also to retrieve all the users, which is a model find retrieves all of them. We can have several versions of this. You can find specific user by their unique identifier. So if I give me given user ID, then I can say model find. And I know there's only one of these, right? So I can use the find one instead. So find retrieves an array, multiple records. Even if there's only one record, find will always return an array of all the records in that collection. Whereas find one, right, and find by ID, both of them only retrieve a single record, right, matched with whatever you pass in here. So find by ID, right, expects the user primary key, right? So like that. And whereas, say I want to retrieve find by username, then that means that I know there's only one of them because username is unique. That's how I declared it in the schema. There's only one username, right, per record. Right? Every record will only have a username. So I know that if I pattern match it, as username matches username, I know only one of them will match. Right? So don't retrieve for me an array because I know there's only one of them. So retrieve that just one. Also notice that we can use the just a tactical shortcut here, right? That if the property is the same name, has the same name as the value or variable, there's a shortcut where you can just say username like that. You can have any number of other functions that might be useful. Say maybe find by credentials, where the credentials might contain the username and password. So username, password, or the credentials, and you might retrieve the particular user, hopefully one, right, that matches the username and the password. And presumably there's only one that matches the unique match, right, of the combination of that username with that password. And you can create all sorts of finders, right, that might be useful for whatever it is that you're building. We'll see later on that this is actually very useful for implementing things such as logging in and registration, things like that, right? Then let's see, we have then complete user, and we provide maybe ID of the user that we want to remove. That is the model delete one that matches the primary key equals to the UID. And probably want to also to update the user, provide the user ID of the user want to remove, update, and then the actual user updates. So these would be the fields that we want to update. Right? And for that, we use the user model update. And this too has two versions, update many and update one. So we only want to update the particular user whose ID matches the user ID that we pass in. Right? So remember that update one takes two arguments. One is the pattern match, so we can identify the record that we want to update. And then the second one is the things that we want to update. Right? For this, we use the set operator, right? That says which fields we want to update. So we might say here, well, the username, right, equals to the user updates dot username, because the user updates already it will be formatted as a user object, right, following this schema. So it already follows the schema. So in effect, the user update is just going to have the few fields that I want to modify. Maybe I want to change my email, I want to change my phone number, or whatever. So actually, running these out, I don't really know what it is that the user modified from the user interface. I don't know which fields they're updating. So, but presumably, user updates only contains those set of fields that have been modified. So here, I don't know if they've actually modified the username. Right? So it'd be silly for me I would have to create some like switch statements and say, well, the username was updated and then set that. So instead, right, I could just, since user updates only contains the fields that have been updated, I don't really need to do any of these, right? I can just say, just do whatever user updates contains. Right? User updates will contain the new email, phone, and that's what set is going to update. Only the fields that are in here. Right? So that's as easy as that. All right, so we have that. Then in the controller, right, we want to use the DAO to be able to create users, update users, and we know that there's a pattern to do that, right? For the URLs that we use, right? For creating, we use post. For retrieval, we use get. For update, we use put. For removal, we use delete. Right? Declared inside of a controller. So let's create the controller. So we're going to use the controller. If you remember, it's going to be a function that takes in an instance of the Express library, right? That's going to allow us to declare the posts, right? The gets, right? The delete, and the put, right? All that is available through the app instance that we pass in, and then we can define the URLs that we want to match them to, and And the convention here is that the URL should include a noun, a plural noun that describes what it is that you're modifying. So for all these, we are interacting with users. Yep. Now for post and get, these two, they are manipulating or referring to the entire collection of users. Right? So post means I'm going to add a new user to the entire collection of users. So there'll be a new element or a new instance in this new collection of users. Whereas get users, it's interpreted as, okay, I want to retrieve the entire collection of users. Give them all to me. Whereas delete and put work with individual instances, right? If I want to delete, I don't mean to remove the entire collection of users, right? Instead, I'd like to specify, which user do I actually want to remove? Right? So the convention is to encode the ID of the record, right? The primary field, unique identifier of the actual instance that I want to remove, right? And we encode it following the name of the collection that we want to remove, right? Of the particular record. Same thing with put. Right? We don't want to modify all the records. We want to modify a specific record, and we encode the unique identifier of that record as part of the URL. So that's a convention, very common convention, of building these URLs in a particular pattern. Right? Now, the actual functions that will do this, can be implemented here as well. And say you want to create a user, right? That is going to actually create the user. So this would be that create user. Then users, and so that could be implemented. Right, it's the actual handler. These are the handler functions that handle the incoming HTTP requests. Right? Same thing with delete. Delete user. And then update user. Okay, and so these are all the handlers that will be invoked when those incoming requests are handled by this controller. Okay. Yeah. All right. Now, all of these functions, right, are participating in a client-server architecture. Right. So the incoming posts or the incoming get, incoming delete, right? That's an incoming, HTTP request that is coming from a client, and with the architecture, the way it works is that your function will be invoked when that HTTP request comes in, and the responsibility of all these functions is to generate at some point a response, right, to whoever requested this service, right? So to do that, all these functions are this post, get, and delete and whatnot, pass these handlers. They pass two variables, right? Request, response. All these handles are participating in this request response. Now these variables, they don't have to be called that. You can call them whatever you want, right? So this could be ABC, and this could be XYZ. Obviously, these are just parameters, right? The parameters can be whatever name you want to give them. But the more common names are just request response. Okay, so what does request response? What does these all do? Well, they use whatever mechanism it is to go actually create this user, right? So what mechanism we have? Well, we have the model. Obviously, the model is the one that we use here. So all these could just plainly use the model to do that. But instead, we wrapped these model functions in with a higher level API, right? So create user in the controller basically would invoke the DAO create user in the DAO. So let's import those. We'll say import everything from the DAO, and we're going to call it here the demo from user demo, so that we can call the create user, and we're going to pass a user object. But where do we get the user object? Right? I mean, that's what it's expecting. Right? It's expecting that it's expecting an instance of the object that we want to insert. Where do we get that from? So this create user, the DAO, is expecting an instance to insert. So that is going to be retrieved from the request. The request, remember, request is whatever comes from the client who's sending all this data, is generating this request. Right? Presumably, we're going to agree that the client is going to provide this data embedded inside of the body. Right? There's 3 different ways that the client could send this data. They could encode it as part of the URL. I mean, that would be one way, right? We could encode in the here in the post. We could encode that you give me the username, right? You can pass me also the password, and so on and so forth, right? All the fields that I need as part of the URL. Well, that's silly, right? It'd be a very long URL. Instead, or the second way that we can encode data is to pass it in the body, right? And that's what we're going to do. We're going to retrieve the user from the request body. Yeah. Okay. The third way is through encoding it as query strings, right after the question mark. But that also would be still in this case. All right. So that this is going to create the user, and we want to that's going to be inserted into a database, and we're just going to capture here the actual user that was inserted in the database, right? See that. Now this call here, the create user, notice that it's using the low-level create. Now this create here is asynchronous, right? So what this returns is actually a promise, right? So we need to wrap this inside our promise handling mechanism. So here we're going to do this needs to be an async, and this is going to be an await. Once we have the actual user, we can then send it back to our client. We can say response. We can send back the actual user, so that they could get a copy of the actual user that was inserted. Right. How about find all users? Well, that also so all these will be async because we are using the model communication with the server, right? And so these will all be asynchronous. So find all users is just retrieving data. So this would be the users from the DAO.find all users. Notice that I am deliberately calling these functions in the controller the same as the functions that I created in the DAO. And I'm doing that as a convention. They don't have to be called the same way. It's so that I can keep it straight in my head, right? That this controller that is receiving the request from the client, right, is being handled by, I'm proxying this, or I'm delegating this to the DAO of the same function called the same, right? Just to keep it straight in my head. And then here we just respond to the users that comes back in the database. Delete. For delete, we need to retrieve the ID of the user from the request that's coming in, and it's embedded inside of the parameters of the path. And for that, we just retrieve from the request params, right? With the same name, the ID here. Now these don't have to match, right? Again, this is a local variable. I can call it whatever I want. But again, I like to use the same names, just again to keep it straight in my head. So this is we're going to be using the DAO.delete user, pass in the user ID. That's going to go out to the server, the database server, right? And eventually going to come back, and it's going to return a status on whether they're successful or not, and how many records did it actually remove. And we can send back. It is a JSON object, encoded of how many records were deleted, whether they're successful or not. So we're going to send that back. Update. We also need the ID of the user, right, which is encoded as part of the URL, so we can retrieve that. But also, we need the updates, right, because remember the DAO update user is expecting, right? It's expecting the UI, the user, the UID, unique identifier, plus it's expecting it's expecting the updates, right? What are the fields and new values that you want to update the record with, right? So where's that? Well, we're going to send that. The clients needs to send the updates. We're going to ask the client to please provide that as part of the body, so we can pass it in. Right? Now, this update, just like the delete, right, it's going to return status of what actually happened, whether it was able to update, with how many records did it update. Hopefully, it will just be one. Okay. All right, excellent. So what about all the other ones here? Find by credentials, find by username, find user by ID. So these will be useful later on for implementing, logging in and registering, and so we'll leave that to a little later. But I just implemented it here just to give you an idea of many other functions that you might want to implement in DAO for whatever purposes. But those will be useful later on. We'll implement later on things such as app.post, register. But we'll do that a little later. We'll do register, log in, log out. Yeah, we'll do that a little later. And for that, right, we'll need these other functions. Okay. So for now, let's see if we can get this up and running. We have the controller. We'll need to export this controller, and then in the app we can import the user. Controller, we say import this controller, and then here controller passive. Okay. All right. Yeah, so let's try it out. We can now restart the server and see if this blows up. So notice that we already had a users in there in the collection of users. So presumably we should be able to retrieve that one user here. We should be able to say 4,000. Okay, so it looks like it's working. Here's our user. A8F92. Hopefully it's this one, A8F92. So yeah, it's retrieved that one record. So what's happening here is that the client right now is just browser URLs. Right? It's going out to that server listening at 4,000. Right, so this server is listening at port 4,000, and the user control had used the app, right, to register a URL that if we got an HTTP GET map to /users, it would go handled by find all users. And find all users went out to find all users DAO, which used the user model.find. User model used the retrieve from the collection users, retrieving an array of all the records in that collection, right? And the DAO is just returning a promise, right, that will be resolved when the data comes back, right? So this is kind of like waiting for it to come back. When it comes back, you get the array of that .find, which is echoing this back to the promise, right? So that's basically what's happening. Right? Now, all the other ones, obviously, we need to implement, right, for these. So to create users, we could try it out by quickly creating a postman here. So let's see if we can create a user. Let's create a new request and call it create user. And this is mapped to the same URL, right? It's the same exact URL. So this is going to be a post. So I need to generate a request that maps. So according to this, right, I need to generate a post that maps to /users, right? A post that maps to /users for 4,000. And according to this, I need to embed in the body the new user. So let's do that. So we can say here, body raw JSON, and say that username, so it's Bob, and password. So this is Bob3, and this is first name. So this is Bob, like that, and this last name. This is Bob. Okay. So save that. Let's run that. See if this blows up. Okay, so it came back. That looks promising, right? So that's data that I sent plus the underscore ID. This is something that Mongoose adds to the record for internal purposes. And we can go out to the database and actually see if it's there. You can refresh and see that indeed we do have Bob Hope. Okay. We can insert, certainly we can insert a few. But instead of doing that, let's head over to the browser, to the React application, and see if we can just play around with these two endpoints, right? The post for creating a new user, and the get, right, to retrieve all the users. Right? So let's do that. Okay, so back in the React application, it's here. Let's see what this looks like. What do we have so far? It's a client. So it gives you a React application. You can search for movies, create movies, search movies, OMDB, blah, 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 whatever. So let's create a new tab where we can fetch users, create new users. Let's see. So in here, let's create a new directory where we have call it users. And this will have an index that renders all the users from the database. Okay. So let's see. We have we'll create here const user list, call it. And so it's going to return for now. Will be just the export default. And so for that, let's create a route, right? That if it's users / user, then it will render our users. Okay. So here, if I go and say users, it renders users, right? But instead of me having to type it, let's add it to our navigation, so that we can just click on that. So it says users, users, and users here. So we have this link. See that? So if you go to home, search, click on users. We have the list of users here. Now we could take a shortcut real quick here just to display it right here on the screen. So for instance, I mean, we are currently using funcs, and we're using services, and we're using all sorts of things. But let me just show you a quick and dirty way of doing this. Not that you should do this, right? You should always follow good practice. But let me just show you real quick how you could probably do this very, very quickly. So first, you need a variable to hold the users. So this would be use state. So this is the array of users. But first, this would be an empty array. Excuse me. And what we want to do is that when we first load, we would like to do what? We want to go fetch these users. Right? We're going to say read Axios, right? We have Axios .get, and the request is that if we want, basically we want to do this programmatically. This call right here, it should be URL like that. See? Now this is going to come back as a let's put it in a function. It's better. Fun. It's a little cleaner. Here's Axios. Right, and here we're going to call find all users. There we go. So this is going to be asynchronous. So async, and here we're going to get all the users, wait, and actually no, that's going to the response, right? So response from the server, and we're going to grab all the users from the response.data, and then we can just say set users and the users. See that? Okay. And when we have that, then we can display, well, how many users are there, right? And then we have this too. So it is indeed fetching those users from the database, right, from the server. We can even iterate over them, right? So we have a UL and get the list group and iterate over the users, right? Users dot map, the way you would normally iterate over this, right? And then display here li key would be user dot underscore ID, right? And render here the user dot username, right? There we go. We have Alice and Bob, and maybe paint this a little prettier. So the list group item. Right, there we go. So these are the records that are being retrieved from the server, right, from this database right there. Now, obviously, notice that we skipped over tons and tons of code for declaring services and declaring funds, right? So this is not the appropriate way of doing it, right? So this is bad design, bad practice, right? But I just wanted to show you how trivial it is to go and fetch data and just put it and pump it to the screen. The proper way of doing this, right, is to instead put all this code, right? All this code should not live here. Instead, it should live as a service. So let's create that. We could say users service, and in here, bring over this function. Right, bring that here, and final users, blah blah blah, get the response, and so this. Notice that this is user UI dependent. That has to do something with rendering the users on the screen, right? So we don't have that here. But this is the only responsibility for this function is to go fetch the data and then just return it. Just return the users, right? Or just do say just return. Right? And services is where you would have all the functions that deal with the controller. The controller has all these functions. Right? As a create user, right? So this would be a replica, right, or mirror image of what the controller is doing. The controller is declaring all these functions, right? Right, for create user, final users, update. So the mirror image of that is the client service. So the client service has the same functions, which is talking to. So find all users is talking to. So find all users in the client service is talking to the find all users in the server controller. And the way they communicate is through HTTP, right? Through this client server network connection, right? Where I am, invoking at 4000 this URL, which is being handled by the controller, here at /users final users, right? Okay. So yeah, so that's a proper design, right? So now that it's defined here, you have you create put all your functions, create user. Obviously, all the other ones go here as well. Delete user, async, user ID, blah blah blah, right? They're all implemented here. So export cons. Again, mirror image of the controller, right? UID, user updates. And so once you have this, right? So the proper thing to do is that instead of doing this, instead of you make the call directly here, is that you bring in that service. You bring in that service index, say import all from service or as service, from user service. User from user service, right? So here, right, instead of doing this, don't do that. Don't use access directly. Instead, you do a service dot find all users. Yeah. Okay. So this works exactly the same way we had before, right? So no difference. Functionally, these are identical. So if I refresh, this works identical as before, right? But right, I'm applying a good design pattern, good practice, right, of breaking up the roles of rendering the data from fetching the data, right? They have two distinct set of concerns, right? So this division of concern is a very, very important principle in software engineering in general. So that's me applying that. Okay. Yeah. So the other principle is that of maintaining state. Right here, the user list is maintaining its own state, right? For instance, here we could implement delete and create, and I could do everything here. Okay, but again, that's not proper. Okay, I should not be maintaining my own state. Instead, we have decided about breaking up those two roles, just like there's like a role for fetching data from the server, and it has its own concerns. The same thing, maintaining state locally here is not proper, right? And so instead, we went out and implemented a reducer, right, to handle that. Right? So we went out and implemented the user's reducer, right, and said const user reducer. We created a slice. If you remember that, right? And in that slice, name and said that users. We keep an initial state. Initial state might be loading, balls, and users is the array, and then we would declare the extra reducers. Now, if this were synchronous, you would have the reducers here, right? But because this is asynchronous and talking to a remote server with the data, right? We are instead going to use the extra reducers and implement thunks, right? And then we export default the user's reducer, the reducer. Okay. So let's do that. Let's create the thunk, right? So that the thunk can pass in the data here into the user, so that we can then send it over and read it from the list properly, not maintaining our own state, but instead the reducer maintaining its own state, right? So to do that, we create the thunk. So this would be users thunk, and so we implemented here, export const find all users. Thunk is a function that we're going to create an async thunk, right? That's going to have a unique name, find all users, and a function that is going to invoke the find all users service. Perfect. Right. Now this find all users is asynchronous. So let's do an await. It's going to return the array. This needs to be async. And that's going to do what? It's going to go fetch the users. It's going to put the users. It's going to return that data of the array of users, and that's what's going to end up where? In the reducer, right? The data that is returned there is going to end up in the reducer as follows. And you say, okay, well, that reducer that I just built, define a user's thumb. When it completes, when it comes back, it's going to put in the action is going to put whatever in the payload is going to put that list of array of users, and we just have to initialize it. You can say that state dot users is going to have the value in the payload, which contains the array of users that comes from the server. Okay. Yeah. And so the last thing is that we need to make that put that in the store, right? That users. I'm going to put the user reducer. There we go. And so that in my list, I can now, instead of using this, I can use proper use selector, right, from state. I can pull out the state.users. Okay. All right. Let's see if that blows up. Set users is that fine? Okay, so yeah, so no longer do we need this. Right? We're not going to do that. Right? We're not going to do that. Instead, we're going to use dispatcher. Say we need dispatcher dispatch. Use dispatcher. Right? And so no longer going to do that. We're going to dispatch. I'm going to call the find all users done. And that didn't work. Let's see. Well, users. Let's see. We might need to restart. See if we get an error. Console promise blah blah blah. Set users not defined. Let's see. Console users navigation. Yeah. Dev tools. Let's see if I need to maybe restart the server. So stop this. Stop. Let's restart. Meanwhile, let's see if I missed out something. Dispatch, blah blah blah. File user thumbs. File user thumbs. Is this? You want async await final users from the service, and the service is going out, retrieving all the users. The response data, that's the array. So that should be put in the payload, and then in the reducer, we never. Wait, did we do this? Oh, I put it in the wrong place. This goes here in the extra users. Let's put that in there. And let's refresh. Well, so users, there we go. Okay. So basically we are where we just left, right? But we are implementing in the correct way, providing the right best cases. Okay. Okay. Yeah. So we're kind of ready to start playing around with being able to log in and register and blah blah blah. So let's play around with that, a little bit of that. So for instance, we would like to be able to register and pass in our username and password and create a new record. Right. So let's do that. Let's create here in users. Right. Let's create a new a new screen and call it register. We'll say account register. So this is a turn like register. And then maybe we'll put maybe a link here for register screen. Right? So let's do that. We'll say app and maybe here a route that says register, and this is the register. And maybe navigation, put another link here. Search users active, blah blah blah. It is getting kind of like annoying having to copy and paste each one of these, right? It'd be nice by just having an array, right? Say, call it screens or something, and just the names of the screens would say, what do we have here? Search users, search. Right, search. And now register. Right? So it'd be cool if I could just do this. Say screens dot app screen, and then for each screen, render one of these. No? And then what would change is that this would be an expression, right? And this would be the screen. And then what else? And then this would also be an expression, right? So this would be equal to screen. Then it would be active. So now I don't have to do that. And let's see, this is the okay. So it looks like okay, users. Oh, that last screen was wrong. No, last screen. Oh, okay. So this is what is also screens. Yeah, search users register. There we go. So now I click register. Search users. Register is not rendering anything. Probably because I never added it to the app. Register. There we go. Probably this should be capitalized. it's just using that screen. It's using that that screen string, right? Maybe we can capitalize it. You can say, let's see, how can we do that? Let's say two. When it comes to work, is there a capitalization function? No. Maybe we can capitalize it with span. Say a class. That's capitalized. See? There we go. See that capitalized. Perfect. Okay. So and so now we can create any number of ones. We can say register, we can say login, we can see that. We can have a, I don't know, profile, and we should be able to navigate to them. Obviously, we don't have a component for any of these, but navigation makes it so much easier to just have an array. All right, so in register, what do we do in register? Let's go back to register. Let's have a couple of input fields that allows us to type in the name, Alice, and password. Three. And here we have an input field that would have the initial value as name, and that if we change it, on change, then say we're going to update, say that set username to the target.yahoo. Okay. Same thing with password. Set password. Okay. All right. So and then obviously can query it up a little bit. Some passes. Make it presentable. Saying form control with facilities down, and we can put some budget CDs on the bottom. I can just up a little bit. Probably want a bottom that says register. And then maybe we can make it prettier. Primary. Go. Maybe we can make it 100% pick up the entire screen, and also put some spacing in between. That this one, right? And so for registry, probably we need two input fields, like one for a password and the other one for validate password. So maybe we can try to make the validate password. So validate password. Make sure that it's the same. Right? Put some error messages. It's the same. For register, we could handle registration here. Handle register button. Right, and maybe we could have an error message if the password is not the same. Okay, so error, set error first. No, there's no error. No errors. No. Yeah. And maybe we can provide here a alert. Red if there's an error. Right now there is no error, but if there were an error, you can like I don't know, passwords must match. Right. I think they need to be work. Yeah, something like that. Password must match. If there is an error. You can say, if there's an error, and it only displays if there's an error. So if the error is null, then it doesn't display. Okay. Let's see, and then for register, you can click on the register button right into on click, call the handle the register button, right? And so we can handle this and say, if password not equal to validate password, then error equal password must match. Right? Else error. Actually, this should be set. Set error. And this is set error. No. So for instance, if this is something different, okay, they're not the same. Set value, password, set value. They're different. And they click on register, right? If instead they match, right, then register, it clears it out. All right. So if the register if it's valid, then we want to create the user, right? We want to create the user, or we want to call register. Register presumably being on the server, this register here, and register presumably create the user. We would do more or less the same thing as is create user, although this create user kind of like a blind create user, right? I just want to create a user. Whatever data you gave me, boom, I'll just create a user. Whereas this register is a little more nuanced. Right? I will create the user if certain things are true. Like for instance, if the username is already taken, then I do not want to create. So I would need to check to see if the username is already taken. If it's not, then yes, I'll let you create the user. Otherwise, I would fail it. It says nope, you can't register. So let's implement that logic. And so register would be handled by a function here. Register. So let's say the const register slash response. Okay, and we're going to call in register here. So register and so who implements this? Right? Well, the AI. But we don't have anybody else that's implement that here. Right here. Register. Export. Register. So here is the user that includes presumably username and password that have already been validated on the client, making sure that the two passwords match. So the only thing that we have here that we care about is that username and password. So first of all, we want to make sure that that username is not already taken. So let's see if you already have a function here that can find a user by the username. You can find const existing user. Is there an existing user? Well, let's go find out. This will be, we have to do an await here. Okay, wait. Find user by the username, and the username is presumably in the user object that you're passing us from the client. Right. So we check to see if there is an existing user. Right. If there's an existing user, then something went wrong. Right. So we're going to actually, it might be useful to try to use this logic. Yeah. Here's the benefit. Find the user, and so if there is already a user, if it already exists, the way we're going to fail this is that we're going to notify the client that Oops, no, the user already exists. I'm not going to let you go through. I'm going to maybe send back an error. What can send back an error is response, send back the status, status. Kind of like 503. 503 is an unauthorized security status, right? An HTTP that client and server can use, right, to know that something went wrong. Right? Just like there's a 404 means that it cannot find a document what you asked for and find it. So this would be and the whole thing. Now, otherwise, right, if the user does not exist, then we are going to create it using the same mechanism that we create over here. So first of all, let's copy this. Let's copy the same kind of thing here. Right? First, read the user from the body. That's where we get the intent. And the user does not exist. User is not taking. I am going to create the user. Here I have the actual user, and I'm just going to respond. Right? Now, probably I don't even need an else. Right? So that's the normal thing is that I would create the user normally. But right, to give us a little more chance to validate and make sure that we're not creating the same user twice. All right, so let's try this out. Let's try this out. Here's my register. And so here's for my client, for my user interface. Certainly we can try it out with Postman. Let's try it with Postman first. Okay? Let's create user. I'm going to duplicate this. Call it register. And so this is register here. Register. And passing in the body. Let's try registering Bob again. Right? Bob should already exist, so this should fail. If Bob is there, same username, so this should fail, right? So we can save that. Start the server again. Let's see, so that I can run this. Let's see, the terminal. Stop. Start it again. And let's see what happens. So I'm going to send it. Okay, service unavailable. Oh wait, maybe it's not 503. maybe it's 403. 403. Yeah. Again. Forbidden. Yeah, that's what the one I wanted. No good. Can't do that. But if instead I send you somewhere else, like send you maybe Charlie, right? This is Charlie 123, and this is Charlie Brown, right? Then send. Then it's okay. That it was okay with Charlie Brown, but not with Bob. Right? Because Bob already existed in the refresh. First that a user is Charlie there. Okay. So basically that's what we wanted to do. How about logging in? So let's implement on the server. How would login work? So login would work as follows. So we have login, and have here const login async request response. And we're going to retrieve the user right from the body, same thing, right? Now, just like in register, the user object that was being sent contains the username and password. Same thing here. Login also is going to contain username and password. So, but I'm going to call it, instead of calling it user, I'm going to call it credentials. I think that's a better name. Which basically I don't really care about the user and password in there. It's not really a whole user; it just has a credentials. Once I have that, basically I'm going to do the same thing here. I'm going to try and find that user by their credentials, right? Where is it? This one, right? I'm going to use this one. Try and find it, user and password. If it exists, then the user is good. Otherwise, it's not. Right? So I'm going to say the same logic, basically. I'm going to say find is there an existing user. If I pass in the credentials.username and credentials.password, pass it in. You know, does it exist? Right? Does it exist? So here's basically the upside down, right? So if it doesn't exist, I'm going to send an error saying, nope, you can't go in. Sorry, that user doesn't exist. Right? But instead, if it does exist, then I don't need to create it. I'm just going to respond with the actual user that does exist. Right? Okay. So yeah, so let's try that again. Let's start again. And let's try logging in. I'm going to duplicate this register. So I'm saying duplicate. And I'm going to log in. Login. And this would be login. Login. And in the body, I'm going to pass in Charlie here. Okay. Now, if I send this, presumably it should return the Charlie Brown object. Who may not be such a server. Oh, we never mapped it. It's the new login. Restart the server. So I'm passing Charlie. So this user password does exist, so it returns the user. If I mistype the password and I send it, right, it should not work. What happened here? This should not have worked. Log in. Oh, not find by username. Not find by username. It's only checking the Charlie, both checking the password. So this really should say find user by credentials. There we go. Start the server again. Let's try again. Okay, now it's forbidden. That's good. It's sending the exception, but if it's Charlie with the correct password, it sends back the whole object. Make sense? Right. I probably don't want to pass in the password and return it. So probably what I want to do is that before sending it back, maybe I want to just remove the password, right, and return it with whatever. Right. So eternal. So if I respond, you can notice that. Oh no, actually, no, meant to create and spread this. Again. Oh. No, that didn't work. What happened here? JSON, blah blah blah. User, existing user. That's weird. Now credentials. Probably I just want to return what? Maybe I just want to return the existing user dot username. Maybe just that. Username, and maybe the first name and last name, right? First name. Oh, actually, we could do here. Actually, no, we could use existing user just fine. Choose existing user. Yeah. But instead, in the prime credential, here we can specify the actual fields we want, and we can say I only really want to send back the username, password. I do not want to include passwords. I can turn that on here. Password false. So the second argument, excuse me, to find one, find by ID, or find, right? They'll take a second argument. The first argument is the pattern match, right? How do I want to pattern match what I want? The second argument allows you to specify which fields you want, which fields you don't want. So you can turn off and say, I don't want I don't want a password. And if you set to true, you retrieve that field. Otherwise, you don't. Right? So let's try it out. Terminal start. So send. Okay, notice that now the password is not being returned. See that? All right. Let's see what else. Yeah. So we have users, passwords. So next, right, we're gonna start talking about being able to associate likes, right, with users. Right? But that will be the topic of tomorrow. Okay. All right. Thank you. I hope this helps.